Welcome back to Programming Fluency. This is section 10.2, Header Files and Include Guards. Every program you write starts by including stdio.h, but you have never written your own header file. In this video, you will learn how and how to protect them. Let's begin. Every program you have written starts with #include of stdio.h. You know that pastes a file into your code, but you have never looked inside that file, and you have never written your own. In this video, you will learn how to write header files, the contract that lets many source files share declarations, and you will learn the three-line pattern that protects them, called an include guard. This is the plan for this video. First, declaration versus definition, announcing that a name exists versus actually creating the thing. Next, your first header file, a .h file that declares and a .c file that defines. Then the double inclusion problem, why the same header can get pasted twice. After that, include guards, the #if_end_def pattern that fixes double inclusion. Finally, sharing variables with extern. Declare it in the header and define it in exactly one .c file. Let's start with the problem headers solve. Your program grows past a single file. Now main.c needs to call a function whose body lives in another file. math_util.c. How does the compiler, working on main.c alone, know that function even exists? The answer is a header file. A header file ending in .h holds declarations. It is the contract that says these functions exist and this is how to call them. The actual function bodies stay in the .c files, so a header separates two things: what exists, which are the declarations, from how it works, which are the definitions. Before you can write a header, you need one distinction that C enforces strictly: declaration versus definition. A declaration introduces a name and its type. It just says, this exists. You can declare a name as many times as you like. A definition creates the thing. It allocates memory for a variable, or it gives a function its body. And a name can be defined only once in the whole program. That rule is called the one definition rule. Look at the code. The first line, int add of int a, int b, then a semicolon, is a declaration, no body. The second one with the curly braces and return a plus b is a definition. It has a body. Now the key rule for headers. A header gets included into many .c files, so it must contain only declarations, never definitions. If you put a function body in a header, then every .c file that includes it gets its very own copy of that function. When the linker combines them, it sees multiple definitions and refuses to link. Look at the split. math_util.h holds only the two prototypes, the declarations. math_util.c includes that header, and then provides the actual bodies, the definitions. Notice that the .c file includes its own header. That lets the compiler check that each definition matches its declaration. This figure shows the whole flow. The header in the middle is the shared contract. Both main.c and math_util.c include the header. It is the one contract they agree on. Main.c relies on the declarations to call the functions add, multiply, and max. math_util.c provides the actual definitions, the function bodies. Then the linker connects them. When main.c calls add, the linker looks up the definition of add in math_util.c and wires them together. Now for the trap. What happens when the same header gets pasted twice? Suppose main.c includes point.h directly. And main.c also includes geometry.h, which itself includes point.h, so the preprocessor pastes the point type once from the direct include and a second time through geometry. Look at the result. Two identical type def structs for point. The compiler sees point defined twice and reports redefinition of point. It stops, and as projects grow with headers including other headers, this double inclusion is nearly impossible to avoid by hand. This figure shows the collision. Point.h reaches main.c along two different paths. The first path is the direct include. Point.h goes straight into main.c. The second path goes indirectly, through geometry.h, so main.c ends up with two copies of point.h's contents, and point is defined twice. Main.c is highlighted in red, because that is where the collision happens. The solution is to make each header safe to include any number of times, so no matter how many paths reach it, its contents appear only once. This is the fix, an include guard. It uses the hash if ndef directive from the last video. Look at point.h now. It opens with hash if ndef point_h, then hash define point_h, the contents go in the middle, and it closes with hash ndef. Watch how it works. The first time point.h is included, point_h is not yet defined. So the preprocessor enters the block, defines point_h, and pastes the contents. The second time point.h is included, point_h is already defined. So the condition is false, and the preprocessor skips everything down to the hash ndef. The contents are pasted exactly once. The guard macro name must be unique across every header in your project. The standard convention is to take the file name, write it in uppercase, and replace dots and slashes with underscores. So point.h becomes point_h. Student.h becomes student_h. Math_utils.h becomes math_utils_h. And a header in a subfolder like io/filereader.h becomes io_file_reader_h. The only real requirement is uniqueness. If two headers share a guard name, one gets silently skipped. So every header you write should have an include guard. No exceptions. Headers let you share functions, but what about a variable you need across several files? For that, you use the extern keyword. Extern declares a variable without defining it. It tells the compiler this variable exists somewhere but not here. Look at config.h, it says extern int verbose mode. That is a declaration only. No memory is allocated. Then config.c includes the header and writes int verbose mode equals 0 with no extern. That is the definition. It allocates the memory exactly once. If you left out extern and just wrote int verbose mode in the header, then every file that includes it would define its own copy, and the linker would report multiple definition. So the pattern is always extern in the header and a plain definition in one .c file. Let's put it together in one table. For a function, the declaration is the prototype, which lives in the header. The definition is the body, which lives in a .c file. For a variable, the declaration is extern int count in the header. The definition is int count equals 0 in one .c file. Type definitions like structs and type defs are a special case. They go in the header because they define a layout, not storage, and every file needs to know that layout. The overall rule stays the same. Declarations can repeat in every file. Definitions must appear exactly once. This is a common bug and a subtle one. Look at utils.h, it has a proper include guard, but inside, someone wrote the full body of square int square of x, return x times x, that is a definition, not a declaration. So every .c file that includes utils.h gets its own copy of square. When the linker combines the object files, it sees square defined multiple times and reports multiple definition of square. People are confused because the header has an include guard, but the guard only stops double inclusion within one single file. Each .c file is compiled separately, so each one still gets a copy. The fix is the rule from earlier. Put only the prototype in the header and the body in a .c file. This is a second bug caused by careless naming. Look at audio.h, its guard is hash if ndef utils_h, but that is the guard name for a different file. Utils.h, maybe it was copied and pasted. If utils.h was included first, then utils_h is already defined. So when the preprocessor reaches audio.h, the guard condition is false, and it skips the entire file. The audio config type is never declared, and any code using it fails with unknown type errors. The fix is simple. Name each guard after its own file. Audio.h should use audio_h. Let's recap. Header files are how you share declarations across multiple source files, and include guards make them safe to include. A declaration says this exists, and a definition actually creates it. You can declare many times, but define exactly once. Headers hold declarations, and definitions live in .c files. Double inclusion happens when the same header is pasted twice, causing redefinition errors. An include guard, the hash if ndef, hash define, hash end if pattern fixes it. Use one guard per header with a unique name. An extern in a header lets you share a variable, which you define in exactly one .c file. Next, you can now split declarations from definitions, but compiling every file together every time is wasteful. In the next video, you will learn separate compilation with object files, the linker, and the static keyword.